Hello everyone, it's been a while. How is everyone doing? In this video, I'm going to show you how you can easily create water splash protection cover for your toilet electricity switch. More often than not, you will come out of your home toilet with your hand wet or not fully dry. The next thing you do is to switch off the toilet lighting. While the probability of getting electrocuted is very low with an electricity switch, there is a possibility of electric shock if the hand is very wet, coupled with many previous instances of accumulated water in the switch. Alright, let's get started with the 3D modeling of the electricity switch cover. Start your FreeCAD. If you do not have a copy of FreeCAD, you can download from freecadweb.org download.php. They are Windows, Mac and Linux version. For this electric switch cover, we need to create two items. One is the cover itself, which is like what you see here. And next is the base that extend out the cover to the entire switch itself. The reason we make two instead of one is because when you print this in the TPU, making it one piece, it will be very difficult unless you have dissolvable support material to print. For my case, since I do not have the dissolvable material, need to print them in two pieces so that it can cover it nicely. Alright, let's get started. First, create a new document. In the new document, you'll create a new body and followed by a new sketch. And we just select XY plane. The first thing we want to create is a rectangle. So select the rectangle tools here, get a rectangle and first constrain the corner to the origin by selecting the edge of this rectangle followed by the origin and constrain it. Next, set the height of the rectangle to 60 mm and the width to 70 mm. Alright, with that we close it, and now with this rectangle we will pad it up to 0.4 mm, and that's the thickness that we required. On the surface of this rectangle we'll create another sketch. Now here we will draw using the line tool to draw vertical line here and horizontal line followed by another vertical line and another horizontal line. Alright. The length of the vertical line is 20 mm, and let's make both vertical line equal by selecting the line and the equal tools. And the horizontal line distance is 30 mm, and likewise we'll make them equal, these two horizontal line equal in length. Next, we're going to select the arc tools here and connect these two points together, and let's do the same on this 2 point here, followed by the top right 2 point and the bottom right 2 point as well. Alright, the radius for this arc is 5 mm and the angle for the arc is 90 degree, and the distance between here is 0. This will make sure that this is 90 degree to it, and from this point to the origin here, the horizontal distance is 20 mm. For the vertical distance is also 20 mm. So now let's make all the radius 5 mm and the angle 90 degree. Same go to this 5 mm with the angle 90 degree as well. And the center of the arc to the top point here, the distance is 0. So this makes sure that it's fully constrained this, and let's do the same for this. The distance is 0. Likewise for this, radius is 5, and now this is fully constrained. We'll close this, and for this we are going to cut a pocket using the pocket tools. So now we create a hole here, which is the pocket we want to create. Alright, we can leave it at 5 mm since this is the only one we want to cut, or you can enter 0.4 if you want to be precise. Alright, the last thing we want to do on the base here is to make all the corner here. Select this, okay, create a fillet of this with 3 mm, and with that we'll save this, call switch base. Alright, done with the base here, and now we need to create the cover for the switch. Next, create a new document followed by a new body, new sketch, XY plane. Same here, we start with the rectangle tools, drag the rectangle tools, constrain the corner to the origin. The height of the rectangle will be 40 mm. The width of the rectangle is 50 mm. We are good with that. Again, pad this thing up to 0.4 mm. On the top of the rectangle, create another sketch. We're going to draw the same round corner rectangle here. Start with the horizontal line, followed by the vertical line. Okay, the height of the vertical line will be 20 mm, and make sure we make both vertical line the same length using the equal tools. And likewise, go to the horizontal line, we set the length to 30 mm. We make sure both horizontal line length is the same. Next, take the arc tool and connect the lower 2 point of the line together, followed by the top left 2 point via arc, and top right 2 point, and the bottom right 2 point. So let's set this angle to the radius to 5 mm and set the angle of the arc to 90 degree, and likewise we want to constrain this with this point to 0 mm, so that now they will be nicely fit onto the rectangle itself. Repeat the same for the top left arc, radius of 5 mm, angle of 90, and constrain these 2 points together with 0. Alright, go to the top right 5 mm for the radius, angle of 90, and constrain the 2 point to 0. Repeat the same for the bottom right, radius of 5, angle of 90 degree. Alright, so what we need to do is constrain this point to the radius. The distance would be 10 mm, and likewise for the vertical distance to the origin is 10 mm, and now we can see that it's fully constrained. Okay, close it. So what we need to do is head this thing up to 3 mm. Alright, so that's how it look like. So what we going to do is go to the bottom of this thing and create another sketch, and we now at the bottom, and we're going to draw the same rectangle with a round corner by repeating the same thing here. So we're going to draw the rectangle, to horizontal line, to vertical line. The vertical line distance will be 18.8 mm, and let's make the vertical line distance equal for both of them. The horizontal length will be 28.8 mm. Okay, likewise make both horizontal line equal. Again, we connect the corner of the rectangle with the arc using arc tools for the top left corner, and followed by the top right and the bottom right corner. So let's set the angle to 90 degree, the radius to 5, and constrain these 2 points to 0. Okay, we'll do the same for this angle 90, radius 5, constrain these 2 points to 0. Do the same for the top right arc with the angle of 90, the radius of 5 mm. Okay, constrain the origin of the arc to 0, and same thing, this angle to 90 degree, constraining this point to the origin, horizontal distance as 10.6, and the vertical distance to the origin as 10.6. Okay, now you can see that it's fully constrained. We close it, and with that we're going to create a pocket here, and the pocket depth is 3 mm. Alright, so you can see that this is how it look like, and if I now rotate, okay, that's how it look like. And next I'm going to create a feeder here with 0.4 mm, right, to make this thing a bit round. And then going to the top here, create another feeder, the top edge here, a feeder of 1 mm. Alright, that's all you need to do with the cover of this switch, and you can now save it as switch cover. With this done, we are done with the 3D modeling of the switch cover, and you can select the object here, export it to switch cover, then we go to the switch base, and likewise select the item and export it to switch base. With the 3D model done and exported to STL format, we are now ready to import the STL into the 3D printer slicer software. Start your 3D printer slicer. Click on Add. We will select the switch base and switch cover.stl. Open them and let's arrange it. Alright, for this the base is fine, but for the cover we want to print it upside down, so you will select just the cover, and on the rotation here we will rotate it by 180 degree. Okay, so that's how this thing look like, right? And in order to print it, we need to make sure that we select the support on build plate. Okay, so for this one we want to print with the TPU, which is the fax material, and for the print speed you can select quality, which is fine, or you can print it in a more detail if you like to. Alright, one, this is okay. As for the infill, it leave at 50%. It doesn't really matter because this is so thin, so you will print 100% anyway. Alright, so let's slice now to see what happened. Okay, so this is how it look like. If you pull the layer, you can literally see how each layer being created. Okay, let's move this thing over here so they can see how this layer look like, right? Okay, let's move it down so you can see that how it look like, with the green color being the support layer for the corner. As for the base, basically it's just print it out the entire piece. Alright, if you are good with this, what you need to do next is to just click on the export G code button here and input the name that you want. For this case, we just leave it as it is and save it. There will be a message pop up here to show you where the export file go to. You can click on the open folder to get the file and copy to your 3D printer for your printing. Let's see how we can apply the cover onto the electric switch. We will use double-sided tape to hold the cover to the switch. Tape the four edges of the switch with double-sided tape. Remember, the cover comes in two parts. We have used hot glue to put them together. Now, apply the cover over the double-sided tape. Now, the switch is fully covered and you don't have to worry water from your wet hand will get into the switch. Thank you for staying with me in the last 12 minutes. Do you like this series of video demonstrating how to use 3D modeling software to create custom solutions for your home challenges? Please help to like the video, share with your friends, and subscribe to this channel. Of course, we welcome any constructive input to make this video better for you, and we will do our best to address any question if you have any. Again, thank you for your attention and look forward to hearing from you soon. See you